Hello students, you are watching ICSE Mathematics and we are solving exercise 8A of chapter 8 Remainder Theorem and Factor Theorem ICSE Mathematics Standard 10. In the last video we have completed in exercise 8A till question number 11. Today we will start question number 12 onwards. Okay, so now let us start question number 12. Okay, in question number 12, we are given the two polynomials. Say the first polynomial is p of x. P of x is equal to ax cube plus 3x square minus 9 and q of x is equal to 2x cube plus 4x plus a. Okay, the divisor over here is x plus 3. Okay, we know that when polynomial p of x is divided by x plus 3, the remainder will be obviously p of minus 3. Similarly, when q of x is divided by x plus 3, the remainder will be q of minus 3, and it is given that the same remainder is left in when both the polynomials are divided by x plus 3. That means we are given that p of minus 3 is equal to q of minus 3. Let us find out. P of minus 3 is a into minus 3 the whole cube plus 3 into minus 3 the whole square minus 9 is equal to 2 into minus 3 the whole cube plus 4 into minus 3 plus a. Okay, minus 27a plus 27 minus 9 is equal to minus 54 minus 12 plus a. Okay, therefore minus 27a plus 18 is equals to minus 66 plus a. Therefore minus 27a minus a is equal to minus 66 minus 18. Therefore minus 28a is equals to minus 84, and therefore a is equals to minus 84 upon minus 28, and therefore a will be equal to 3. So this is the answer. I hope you have understood question number 12. Now let us solve question number 13. Okay, here one polynomial is given and two different divisors are given. We are given two different remainders in each case. Okay, let us name the polynomial as p of x. Polynomial p of x is 2x cube plus ax square plus bx minus 2. Okay, divisor 1 and divisor 2. Okay, it is given that when p of x is divided by 2x minus 3, the remainder will obviously be P of 3 by 2, yes or no? And it is given that value of P of 3 by 2 is already given. The remainder is 7 in the first case, clear? And therefore 2 into 3 by 2 the whole cube plus A into 3 by 2 the whole square plus B into 3 by 2 minus 2 is equal to 7. 2 into 27 by 8 plus A into 9 by 4 plus B into 3 by 2 is equal to 7 plus 2. 2 4 therefore 27 by 4 plus 9A by 4 plus 3B by 2 is equal to 9. Okay, let us further solve. First, we can take 4 LCM, yes or no? Therefore, 27 plus 9A plus 3 to the 6B, 9A plus 6B upon 4 is equals to 9 4 36, 36 upon 4, clear? And therefore 27 plus 9A plus 6B is equal to 36. Therefore 9A plus 6B is equal to 36 minus 27. Therefore 9A plus 6B is equals to 9. Let us take 3 common. So 3A plus 2B is equal to 3. Okay, so this is equation number 1. Okay, now it is given that when P of x is divided by some other divisor is x plus 3, the remainder is obviously P of minus 3, and it is given that value of P of minus 3 is given in the question, which is minus 20, and therefore P of minus 3 will be 2 into minus 3 the whole cube plus A into minus 3 the whole square plus B into minus 3 minus 2 is equal to minus 20. Okay, minus 54 plus 9A minus 3B minus is equal to minus 20 plus 2. Therefore 9A minus 3B is equals to minus 20 plus 2 will be minus 18 plus 54. Therefore 9A minus 3B is equal to 36. Let us take 3 common. Therefore 3A minus B is equal to 12. Okay, this is second equation. Now solving 1 and 2. Solving equation 1 and 2. The first equation is 3A plus 2B is equal to 3. 3A plus 2B is equal to 3. And second equation is 3A minus B is equal to 12. Okay, we can solve directly. 3A get cancelled, 2B plus B, 3B is equal to minus 9, implies B is equal to minus 9 upon 3 will be minus Now we can substitute value of b in any of the equations. Therefore, substituting value of b in equation 2. Now what is equation 2? 3a minus b is equal to 12. 3a minus b is equal to 12. This is equation 2. Therefore 3a minus value of b is minus 3 is equals to 12. Therefore 3a plus 3 is equals to 12. Therefore 3a is equals to 12 minus 3. Therefore 3a is equals to 9. Therefore a is equal to 3, and therefore the value of a is 3 and value of b is minus 3. Okay, so we have completed the first exercise, that is exercise 8a. Now let us start exercise 8b. Factor theorem have already been explained. If x minus a is a factor of polynomial p of x, then the remainder p of a is equal to 0. Okay, so using this theorem we can start the next exercise, that is exercise 8b. Okay, question number 1. Using factor theorem, show that using factor theorem we have to show that number 1, x minus 3 is a factor of the polynomial x cube plus x square minus 17x plus 15. Okay, so obviously if x minus 3 is a factor, okay, then we know that p of 3 must be 0. P of 3 must be 0. Now let us find out p of 3. So p of 3 is equals to 3 cube plus 3 square minus 17 into 3 plus 15. Therefore p of 3, 27 plus 9, 17 3s are 51 plus 15, 36 plus 15. Okay, so we have 51 minus 51. This is p of 3. Therefore p of 3 we got to be 0, and therefore we can write x minus 3 is a factor of given polynomial p of x. Clear? Okay, so similarly we can solve the second one. Number 2, here polynomial p of x is given x cube plus 4x square, x cube plus 4x square plus 5x plus 2, and divisor is x plus 1. Okay, we know that if x plus 1 is a factor of polynomial p of x, then we know that p of minus 1 must be equal to 0, and therefore we'll find out p of minus 1 the whole cube plus 4 into minus 1 the whole square plus 5 into minus 1. plus 2. Therefore, P of minus 1 is equal to minus 1 plus 4 minus 5 plus 2 is equal to 6 minus 6 is equal to 0, and therefore we got the value of P of minus 1 to be 0, and therefore we can write now x plus 1 is a factor of P of x. Clear? Okay, now let us solve the third one. Okay, here the polynomial P of x is given to be 3x cube plus x square, 3x cube plus x square minus 20x plus 12, and here divisor is 3x plus 2, 3x minus 2. Okay. We know that if 3x minus 2 is a factor of P of x, then P of 2 upon 3 must be equal to 0, and therefore we'll find out P of 2 upon 3 is equal to 3 into 2 upon 3 the whole cube plus 2 upon 3 the whole square minus 20 into 2 upon 3 plus 12 is equal to 3 into 8 upon 27 plus 4 upon 9 minus 40 by 3 plus 12 by 1. Okay, we can reduce by 9. So we have now 8 by 9 plus 4 by 9 minus 40 upon 3 plus 12 upon 1, taking 9 LCM. Okay, so we have 8 plus 4 minus 120 plus 108 is equals to 120 minus 120 upon 9 is equal to 0 upon 9 is equal to 0, and therefore P of 2 upon 3 is equal to 0, and therefore we can write down that 3x minus 2 is a factor of P of x. Clear? Similarly, fourth one we can solve. Okay, in fourth one also we'll take the same 3x minus 2 only, so that you can try yourself, because divisor is 3 minus 2x, so again value of x will be, okay, in this case value of x will be 3 upon 2, yes or no? Okay, let us solve, no problem. P of x is 2x cube minus 9x square, 2x cube minus 9x square plus x plus 12, and divisor is 3. Okay, we know that when 3 minus 2x is equated to 0, we get 2x is equal to 3, or value of x is 3 upon 2, and therefore the remainder will be 3 upon P of 3 by 2, yes or no? So when or if three minus 2x is a factor of P of X, then P of 3 by 2 is equal to 0. Okay, so let us find out. Therefore, P of 3 by 2 is equal to 2 into 3 upon 2 the whole cube minus 9, 3 upon 2 the whole square plus 3 upon 2 plus 12. Therefore, P of 3 upon 2 is equal to 27 by 8 minus 9 into 9 by 4 plus 3 by 2 plus 12. Okay, 2 4s are. So 27 upon 4 minus 81 upon 4 plus 3 by 2 plus 12 by 1. Okay, so take LCM is equal to LCM is 4, 27 minus 81, 27 minus 81 plus 3 2s are 6 plus 6 plus 48. So 40 plus 30, 78 plus 3, 81. Okay, so we have 81 minus 81 upon 4, which is equal to 0 by 4, which is equal to 0. Okay, and therefore value of P of 3 by 2 is 0, or in other words remainder is 0, and therefore we can say that 3 minus 2x is a factor of P of X. Here, so with this question number 1 is over. Now let us solve question number 2. Okay, we have to use factor theorem to show that a polynomial is given. P of X is equals to 2x square plus x minus 6. We have to show that x plus 2 and 2x minus 3 are factors of P of X. Clear? Okay, now if we know that if x plus 2 is a factor of P of X, then P of minus 2 must be equal to 0. Let us check whether P of minus 2 is equal to 0 or not. 2 into minus 2 the whole square plus minus 2 minus 6. 8 minus 2 minus 6 is equal to 8 minus 8 is equal to 0. Therefore, P of 2 is equal to 0, and therefore we can write that x plus 2 is a factor of P of X. Okay, now if 2x minus 3 is a factor of P of X, then P of 3 by 2 must be equal to 0. Let us check whether P of 3 by 2 is equal to 0 or not. 3 by 2 the whole square plus 3 by 2 minus 6 is equal to 2 into 9 by 4 plus 3 by 2 minus 6 is equal to 9 by 2 plus 3 by 2 minus 6 by 1, which is equal to 9 plus 3 minus 12 by 2. So 12 minus 12 upon 2 is equal to 0 by 2 is equal to 0, and therefore we got P of 3 by 2 is equal to 0, and therefore we can write down 2x minus 3 is a factor of P of x. Clear? So second question of exercise 8b is also over. Now let us solve the third question. Okay, here polynomial is given. P of x is equal to 2x cube plus ax square plus 11x plus a plus 3. Okay, now we have to find that for what value of a the given polynomial p of x is exactly divisible by 2x minus 1. Okay, if the divisor is an exact divisor of a given polynomial, that means the remainder will be 0. So if p of x is divided by 2x minus 1, or if p of x is exactly divisible by 2x minus 1, then the remainder will be 0. So we know that if p of x is exactly divisible by 2x minus 1, then we know that the remainder p of 1 upon 2 must be equal to 0. Therefore, p of 1 by 2 is equal to 0, and therefore 2 into 1 by 2 the whole cube plus a into 1 by 2 the whole square plus 11 into 1 by 2 plus 1 by 2 plus 3. Okay, it is a, not x, so we'll write a plus 3 only. Okay, is equal to 0, therefore 2 into 1 by 8 plus a into 1 by 4 plus 11 by 2 plus a plus 3. Okay. Therefore 1 by 4 plus a by 4 plus 11 by 2 plus a plus 3 upon 1 is equal to 0. Therefore, let us take LCM. LCM will be 4. So 1 plus a plus 22 plus 4 into 1 plus a plus 22 plus 4 into a plus 3 upon 4 is equal to 0. Therefore, 23 plus a plus 4a plus 12 is equal to 0. Therefore, 5a is equals to 30 minus 35, and therefore a is equals to minus 35 by 5, and therefore value of a is minus 7. Okay, so here we have completed second of question number 3. Now let us solve the fourth question. Okay, what must be subtracted from? You are given a polynomial 16x cube minus 8x square plus 4x plus 7. Okay, and the divisor is given to be 2x plus 1. When you divided the polynomial p of x by the divisor 2x plus 1, some remainder is left. Yes or no? Now we have to find the number that must be subtracted from the given polynomial in order to bring the remainder 0. So obviously that number which is going to be subtracted is always the remainder itself. Yes or no? For example, if you are dividing uh, for example 9 by 8, then we know 9 by 2, then we know that 2 4 are 8, so we have one remainder. Yes or no? And if we are going to subtract, so if you want to remove this one remainder and bring the remainder 0, then obviously from the dividend 9, if you subtract 1, that is the remainder itself, then the number obtained will be 8, which is exactly divisible by 2. Yes or no? 2 4 are 8, such that the remainder is 0. In short, I mean to say that we have to do nothing but to find the remainder. Yes or no? And that remainder is the answer. Or in other words, it is the number which must be subtracted from the given polynomial p of x such that it is such that 2x plus 1 becomes a factor of p of x. Okay, so now let us solve. Okay, so when p of x is divided by 2x plus 1, the remainder is p of minus 1 upon 2. So let us calculate remainder. P of minus 1 upon 2 is equal to 16 into minus 1 upon 2 the whole cube minus 8 into minus 1 upon 2 the whole square plus 4 into minus 1 upon 2 plus 7 is equal to 16 into minus 1 upon 8 minus 8 into 1 upon 4 minus 4 into 1 by 2 plus 7, 2 2s are, 4 2s are, and 8 2s are, so minus 2, minus 2, minus 2 plus 7 is equal to minus 6 plus 7, and therefore p of minus 1 by 2 is equal to 1. Obviously, we will subtract 1 from p of x, okay, such that 2x plus 1 is a factor. So we'll write down therefore 1 must be subtracted from p of x such that it is divisible, or such that 2x plus 1 is a factor of p of x. Clear? So we have completed here question number 4. Now let us solve question number 5. Okay, question number 5. We are given a polynomial over here. P of x is equal to x cube. X cube minus 7x square plus 15x minus 9 is a polynomial, and the divisor is given x minus 3, we have to show that x minus 3 is a factor of p of x. Obviously, if x minus 3 is a factor of p of x, in that case the remainder p of 3 must be 0. So we'll write down that if x minus 3 is a factor of p of x, then p of 3 is equal to 0. Let us find out p of 3. Therefore, p of 3 is equal to 3 cube minus 7 into 3 square plus 15 into 3 minus 9. Therefore, p of 3 is equal to 27 minus 9, 15 minus 9. Therefore, p of 3 is equal to 27 minus 63 plus 15 minus 9. Therefore, p of 3 is equal to 27. Okay, here we have done one mistake, a small mistake over 15 threes. I will write over here 45. Okay, so I am correcting, this is 45. Okay, now 40 plus 20 is 67, 72. So 72 minus 72 is equal to 0, and therefore we got the remainder p of 3 to be 0, and therefore we can say that x minus 3 is a factor of p of x. Okay, now we have to completely factorize the given polynomial. So let us divide the polynomial p of x by p of x is x cube minus 7x square plus 15x minus 9 will be divided by x minus 3. Okay, obviously first we'll multiply by x square. So we have x cube minus 3x square, change the signs, plus minus x cube will get cancelled, minus 7 plus 3 will be minus 4x square, take 15x down. So now by minus 4x will multiply, and therefore minus 4x square minus minus plus 12x, change the sign. Okay, so 15 minus 12, 3x minus 9, multiply finally by 3, and therefore we have 3x minus 9, remainder will be 0, and therefore p of x can be written as a product of quotient divisor into quotient. Now quotient is a quadratic expression, so we can further factorize the quadratic expression. We have to find the factors of 3 such that the sum is 4. So 3 ones are 3. Therefore px x square minus 3x minus x plus 3. Okay, from the first two terms x common, and from the last two terms minus 1 common. Therefore p of x is equal to x minus 3 into x common x minus 3 minus 1 common x minus 3, and therefore p of x is equal to x minus 3 into x minus 1, and therefore p of x is equal to x minus 3 the whole square into x minus 1. So we have completed question number 5. Okay, now let us solve the next question, that is question number 6. Okay, now question number 6 is similar to question number 5. I hope that you can solve question number 6 yourself. So 6 and 7 are similar. Okay, let me solve now question number 8. In question number 8, the polynomial p of x is given to be 2x cube plus 3x square, 2x cube plus 3x square minus 5x minus 6, and the divisor is 2x minus 3. Okay, we know that if 2x minus 3 is a factor of p of x, then p of 3 upon 2 must be equal to 0. Let us calculate p of 3 upon 2. So 2 into 3 upon 2 the whole cube plus 3 into 3 upon 2 the whole square minus 5 into 3 upon 2 minus 6 is equals to 2 into 27 by 8 plus 3 into 9 by 4 minus 5 3 is 15 by 2 minus 6. Okay, 2 4 so 27 by 4, 27 by 4 plus 9 3 are 27 by 4 minus 15 by 2 minus 6 minus 15 by 2 minus 6 by 1, take 4 the LCM. Therefore 27 plus 27 minus 30 minus 24 is equal to 54 minus 54 by 4 is equal to 0 by 4 is equal to 0. Therefore P of 3 by 2 is equal to 0, and therefore we can write that 2x minus 3 is a factor of p of x. Okay, now let us factorize the given polynomial p of x. Okay, now let us divide the polynomial p of x. That is question number 8 we have. So polynomial is 2x cube plus 3x square, 2x cube plus 3x square minus 5x minus 6, okay, is to be divided by 2x minus 3. Okay, so first we'll multiply by x square. Okay, so 2x cube minus 3x square minus plus, okay, 2x cube plus minus gets cancelled, 3 plus 3, 6x square minus 5x. Now we'll multiply by 3x, so plus 3x, so 6x square minus 9x minus plus, okay, 9 minus 5, 4x minus 6. Let us multiply finally by 2. Okay, so 2 2s are 4x minus 6. Remainder is 0, and therefore p of x can be written as a product of the divisor and quotient. Quotient is a quadratic expression, x square plus 3x plus 2. Now we can factorize this quadratic expression. Therefore p of x is equal to 2x minus 3, 2x minus 3, okay, into 2 ones are 2, x square plus 2 2x plus x. Okay, we can take common x common from the first two terms, x plus 2 plus 1 common x plus 2. Okay, and therefore p of x is equals to 2x minus 3 x plus 2 into x plus 1. So here we have completed question number 8. Okay, now question number 9 onwards we will solve in the next video. Today we started from question number 12 of exercise 8A, and we have ended after completing question number 8 of exercise 8B. Question number 9 onwards we'll solve in the next video. Since there are only 22 questions, so we can try to complete this chapter in the next video. Take care. Thank you very much. Goodbye.